All right, we're going to graph tangent and cotangent today. And to get this started, I'm going to have you just pause this video and fill out the table. Use a unit circle to find values of tangent at negative pi over 2, negative pi over 4, etc. So at the very minimum, just come up with these values of tangent of theta. If you want to take it one step further, go ahead and plot those things on the graph. And that's how we're going to introduce tangent and cotangent. So after you unpause, we'll go through all this. So graphing tangents and coming up with these values here. Let's just check those first. Anytime we divide by 0, we get something that is undefined. Okay, all other values are negative 1, 0, 1, negative 1, 0, 1. Now, this undefined part of the graph, okay, this is something we saw with secant and cosecant. I was just walking around talking with a few groups here. Yesterday, one of the first things that I had you all answer was, why do we get, well, I don't want to say the question because that answers it. Remember yesterday I had you all take a sheet of paper and rip it into 4, right? And you had to answer the question. And the answer to that question was domain restrictions, okay, when we divide by 0. So when we have domain restrictions and we divide by 0, what does that make on the graph? Somebody help us out. When it's on a vertical asymptote, 100% of the time, okay, for any function, if it's a domain restriction, we get vertical asymptotes. That was a big kind of focal point when I introduced secant and cosecant on Friday. Okay, that was also something we chatted about yesterday. So all of these undefines, those are going to be vertical asymptotes there because our graph can't equal that value. Okay, so at negative pi over 2, there's a vertical asymptote. And then again at pi over 2, there's a vertical asymptote. And then based on the values we have here, we get another one at 3 pi over 2. Then the points in between the asymptotes, at 0, I get a y value of 0. At negative pi over 4, I get negative 1. And pi over 4, I get 1. So when we connect these dots, or these points, it ends up looking kind of like a cubic function. Okay, the secant, cosecants work a lot like square roots. These are more like cubics. And then over here, it's just the exact same thing. And it just repeats. So we could even add in another asymptote over here at negative 3 pi over 2. Negative pi is 0. Left one, down one, right one, up one. Yeah. So looking at this graph, okay, because a big thing that we've focused on is the period and the distance of the period. Looking at this graph, can somebody answer and tell us what the period is? How long does it take for the graph to repeat?
Pi over 2.
Pi over 2 is halfway. Pi. Yeah, our period equals pi. Okay, very different than sine, cosine, secant, cosecant, right? Because now we're going through one full cycle just by traveling a distance of pi. Now, when you think about the unit circle, that shouldn't kind of match up with our values of y divided by x, right? Think about in the unit circle, okay, over in quadrant 1, where x and y are both positive, okay, we're going to get positive values for tangent there. But then in quadrant 2, now we have x to be negative and y to be positive. So we're going to get tangent to be negative in quadrant 2. But then when we move down to quadrant 3, both x and y are negative. So negatives by negatives makes tangent positive. So we get the same values that we would get in quadrant 1. In quadrant 4, where x is positive and y is negative, I'm going to get tangent to be negative, which is the same values we would get in quadrant 2. Okay, so that's why the period for tangents is just pi. We go through one full cycle every. Right, now the next thing that I want us to add in here, because we're going to actually graph these just slightly different. Okay, they have a different shape. The asymptotes are a big focal point here. And so I want us to make a note on the side here that the parent function, so let's say parent of tangents of theta, has starting, let's go asymptotes at x equals negative pi over 2 and x equals pi over 2. And so that's essentially how we're going to graph these functions. We're going to think about, okay, where are these starting asymptotes at? Okay, so when we start applying transformations, whether that be a phase shift, a period change, or whatever, these asymptotes are going to move where they start. Okay, so a lot of our work is going to revolve around finding these first two asymptotes. Okay, so we are going to graph it or take a little bit of a different approach than what we did with sine, cosine, secant, cosecant. Yeah, Peter, go ahead. Negative pi over 2 and then pi over 2. These are x's. You can do theta. Since I use theta in there, it might make more sense to have used theta. Okay, but x, theta, and I'm using those interchangeably. They're the inputs. Okay, it's all the same. Okay, so now for cotangents, we essentially get the same values, but just at different places. So we get 0, 1s, negative 1s, and undefineds. But this time, our undefineds are at 0, which is a vertical asymptote, and then at pi. So we'd have another one at negative pi. And a lot of like what we focused on with sine, cosine was what kind of happens at the full period, half period, quarter period marks. We can still use that, where every time in the middle of our period will be those midline points. And I can check that with this table, right? Pi over 2 is 0, negative pi over 2 is 0, and then 3 pi over 2 would be 0. Okay, so for both tangent and cotangent, your halfway point between your period is going to be on that midline. Now, as we shift that midline, those points are going to move up or down. And then the amplitude, there's not really amplitude, so that's not the correct terminology, but we'll still use it. But the amplitude ends up being, for tangents, okay, if I go right 1, how far up or down? The amplitude here was 1, so I went right 1, up 1. Tell me if I go left 1, I need to do the opposite and go down 1. Okay, with cotangent, instead of going right 1 and then up by the amplitude, I'm going to go left 1 and then up by the amplitude, and then right 1, down 1. So it's just the opposite. But it's going to have the same shape after we connect our dots. Still looks like a cubic function, but reflected across the y-axis there. Okay, and then even still, our period here is pi. And the one thing that, so there's two distinctions between tangent and cotangent. One is that tangent is going to look like the parent function of a cubic function. Cotangent looks like one that's reflected across the y-axis. But then it's the asymptotes that are kind of the biggest difference here. So the parent of cotangent of theta are asymptotes are at x equals 0 and x equals pi. Okay, or theta equals 0 and theta equals pi. Okay, and then we're gonna, once you flip this over to the back side, you'll see at the top I have our functions of tangent and cotangent with transformations in there. Let's just remind ourselves what each of those values do. All right, so all the same transformations, all in the same places. So A, that value in front of tangent, that's our amplitude. Again, it's not really amplitude. Let's put it in quotations just so that we're being a little bit more correct. Because, right, amplitude is distance from midline to max or minimum. We don't have maximums or minimums on these graphs, right? If you flip that thing over, that graph is actually going all the way up to positive infinity and down to negative infinity because of the asymptotes there. Okay, so it's more of like our vertical stretch in this case, okay? A stretching or a compressing, not necessarily an amplitude. The period, well, with sine, cosine, secant, cosecant, it was 2 pi over b. But now that our period for the parent functions of tangent and cotangent are pi, now it's pi divided by b. The phase shift is still c, and the vertical shift is still d. Okay. So here's how we're going to go about graphing these. Like I said, we basically focus on the asymptotes. And so essentially what we're going to do to locate these asymptotes is we're going to take whatever we're taking the tangent or cotangent of. So everything in the parentheses. And we're going to set it equal to our starting asymptotes on the parent functions. So down here, I'm going to set 2 theta equal to negative pi over 2. And then I'm going to also set 2 theta equal to positive pi over 2. And the reason I'm choosing this negative pi over 2 and pi over 2 is because that's where the parent function has its asymptotes. And so these values are going to change based on this period change. Okay, so now our task to find the asymptotes is to get theta by itself. So I'm going to divide both sides by 2. And so over here I get theta equals, that's negative pi over 4. And then over here that's theta equals pi over 4. Okay, so I'm going to fill those in. Each tick mark here represents a pi over 4. So I'm going to fill this first one in a negative pi over 4 and positive pi over 4. All right, so now before we do anything else, let's identify the other kind of key features here. So amplitude, should always just be in quotations, is 2. The period, 2 pi divided by 2 is pi, or let's try that again. How about pi divided by 2 is just pi over 2. Are we seeing that? Is our distance between these asymptotes pi over 2? Yeah, it's 1 pi over 4 plus the second pi over 4. The phase shift, there's none here. The midline is down 1, so at y equals negative 1. And we've dealt with the asymptotes here. So I can fill in, let's fill in the midline. It gets a little cluttered at that point, but it at least helps us remember that the starting point, okay, or kind of like the first point that I'm going to go to plot on that midline is the halfway period mark. So I'm going to go halfway to my period and put a dot on that midline. So the amplitude, or that A value, gets applied when we go to basically our quarter and 3/4 period distances. And it's not just going over 1 here, right, because of that period change. So the half or quarter period distance, okay, I'm basically going left by half a square and right by half a square. So if I go right by half a square, that's where I apply the amplitude. So right by half square needs to go up 2. Left by half a square needs to go down 2. And that's because this is our quarter period distance, half period, 3/4 period. And the shape is all the same. This one's hard to, it looks almost like a straight line, but it should have that cubic kind of look to it. And so now I can just repeat this graph in both directions. So I'm like, okay, every 2 squares, which is equal to every pi over 2, I'm going to get another asymptote. Halfway between the asymptotes, we're on that midline. And then halfway between the midline and the asymptotes is where we're applying the amplitude or that vertical stretching. And let's do one more off to the left. So left 2 squares. Midline in the middle. Halfway between midline and asymptote is where we're applying the vertical stretching compression. And there we go. And that's it. Try the next 2. Let's see how they go. Okay, try the next 2. Use pencil just in case some things end up not right, and then we can fix them real quick. But yeah, try next to you and we'll go over them. And there's one thing on the homework that I want to do with y'all too. Do this. We're going to change number 2 to be theta over 2 instead of theta over 3, just so that it fits on the graph better. Okay, so change that to be theta divided by 2. Yeah, so that changes this to be pi over 2. Oh yeah, good call, because it's pi divided by 1/2, which ends up being 2 pi. My bad. Yeah, 2 pi. Okay, take it from there. All right, let's look at 2. So with it being cotangent, I should just expect it to be oriented another direction. So instead of it looking more like the cubic function where I go up to the right, now I'm going up to the left. So that's one big difference there. Now, the other difference is here with the asymptotes. Okay, remember we're going to take what's inside the parentheses and set those equal to our starting asymptotes based on the parent function. And with cotangent, that was at 0 and pi. So by setting that equal to 0, or basically what we're doing here is we're finding where our new asymptotes are located. And that factors in both the period and the phase change. Okay, so that's why we're kind of taking this approach rather than shifting everything like we did with sine and cosine. Okay, so your asymptotes based on the period change here are at 0 and 2 pi. Okay, which basically matches up with what the period is. Okay, so asymptote at 0, 2 pi, and negative 2 pi. We still have that point in the middle of our period on the midline. And then the other 2 points where we apply the amplitude or the A value happen halfway in between the midline and the asymptote. This time I'm going left and then up since it's cotangent rather than right and up like we did for tangent. And I'm going up 2 because of that A value being 2. It's stretching that parent function out. So again, it's more like the vertical stretch than the amplitude there. All right, questions here on 2. So I took what's inside the parentheses, the theta divided by 2, and I set it equal to where the original asymptotes were located on the parent function. So that's why we wrote this down at the bottom here. Because in the parent function, the asymptotes start at 0 and then again at pi. And so when we take what's inside the parentheses and set it equal to where those asymptotes started, again, it factors in both the phase change, the period change, and then if there's a phase shift, it'll catch that too. Okay, so every single time with tangent, when you want to find your new asymptotes, take what's inside the parentheses, set it equal to negative pi over 2 and pi over 2. When it's cotangent, take what's ever in the parentheses, set it equal to 0 and pi. And we're going to do that one more time with number 3. Okay, and I kind of started on number 3, just identifying some of these key features here. So 2 pi, pi over 4, and negative 1 for the midline. But I haven't done the asymptotes yet. So the asymptotes, and this is why we're doing it this way, they're all going to be shifted right by pi over 4, so right 1 squared. If we did that like how we had graph sine and cosine, we're going to end up with so many asymptotes on our graph, we lose track of which ones apply to this function we're actually trying to graph, and then the original function that hasn't been shifted. So that's why we're taking this different approach. So what I'm going to do to find my asymptotes, I'm going to take what's in those parentheses there, so theta minus pi over 4, and I'm going to set it equal to where the original asymptotes were located, which was negative pi over 2. And I'm going to also set theta minus pi over 4 equal to positive pi over 2. And so we'll do a little fraction work here. So I'll first take negative pi over 2 and add pi over 4. And over here, pi over 2 and add pi over 4. Now, we should be getting common denominators. I'm going to do that without showing the work here. So that's negative 2 pi over 4. So negative 2 pi over 4 plus 1 pi over 4 is negative pi over 4. If need be, actually write it out and do the work to get the common denominator. And then here, pi over 2 is equal to 2 pi over 4. If I add 1 more pi over 4, that makes us 3 pi over 4. And so that's where our asymptotes are going to be located. Negative pi over 4. And then Each tick mark is pi over 4, so 1, 2, and then 3. And again, this distance here, that is still our period. Okay, this is still a period of pi. Right? 1/4, 2/4, 3/4, 4/4. Okay, so we're still seeing that period of pi. So now to fill in the rest of the graph, midline has been shifted down 1. Halfway in between that period is where we're going to put our point on the midline. So that's at positive pi over 4. And the amplitude, again, I'm just going to start saying the vertical stretch. So the vertical stretch here is 2. So if I go halfway between this midline and that asymptote, I need to go up by that a value. And then the other direction, I'll go down. When those points are stretched out, it's hard for me to get the accurate shape. It looks more like a line. I won't be picky about that. But that's it. And then we can repeat this. So I know that I have an asymptote every 1, 2, 3, 4 squares, so every distance of pi. So 1, 2, 3, 4. I'll add in another. Everything. The asymptotes, the points. Yep, by doing this work down here. This took care of the shifts. And then right 1 up 2, left 1 down 2. Yeah, we take care of the shifts and the period change with the asymptote work that we just did. Identify some of the key features here. Amplitude, again, it's not the amplitude, but it's going to be, this is why I don't want to call it amplitude. It's -1, and that's why we're going to just put the amplitude in quotation marks, okay? It's not amplitude here. There's no amplitude with tangent and cotangent, so that's more of a typo on my part. Okay, so every time you see amplitude, think of that more as our vertical shift. Now, with every other graph, what did the negative do to like sine and cosine? What did it do to the quadratic? It reflects it. That's going to be the same case here, okay? And I'll show you kind of how we can see that using our parent function, okay? So this is more like a vertical, there's no vertical stretch. It's simply just a reflection. And a reflection across x-axis. Okay, so there is no amplitude because amplitude is distance from midline to a maximum or minimum. Amplitude does not apply to tangent and cotangent. The period, we don't even need to factor out the 3 from this. If you want to, by all means, do it. Okay, but we don't need to do that because we're not, well, I guess we do to identify the phase shift. But for how we're going to graph it, we don't need to worry about that. Okay, so let's come back to the phase shift here in a second. The period is pi divided by b, so pi divided by 3. The midline is y equals -1. And let's figure out these asymptotes. So I'm going to take everything in the parentheses, so 3 theta plus pi over 4, and I'm going to set it equal to where the asymptotes were for the parent function. And with cotangent, that was at 0. And I'm going to do it again and have 3 theta plus pi over 4 equal to pi. And now we just need to solve for theta here. And that's going to tell us where the new asymptotes are, including the phase shift, and also includes the period change. So I'm going to first subtract pi over 4 in both cases. So this is 3 theta equals -pi over 4. And then 3 theta, 4 pi over 4 minus 1 pi over 4 is 3 pi over 4. And then to get theta by itself, I need to divide everything by 3. So this becomes theta equals -pi over 12. And then theta equals 3 pi over 12, which reduces down to pi over 4. So these are where our new asymptotes are located. All right, questions here? 3 pi over 12. So when I divide by 3, the 3 pi over 4 divided by 3, I'm basically taking 3 pi over 4 and multiplying it by the reciprocal of 3 since I'm dividing it by 3. So it becomes 3 pi over 4 times 1/3, which is 3 pi over 12. And that reduces down to pi over 4. Okay, so it's just me doing the division, but instead of me dividing it, how we divide fractions, we take the numerator, multiply it by the reciprocal of the denominator. Okay, exact same work we saw when we were finding the phase shift, or factoring out that value from the phase shift there. Other questions here? Okay, so our graph here is blank. Okay, and again, we can kind of decide what we want each little tick mark to represent. We want to keep in mind kind of what our asymptotes, what denominators and what values we're seeing in our asymptotes. Okay, with this being 1 pi over 12, I think having each tick mark be a pi over 12 would be a good idea. So this first one would be negative pi over 12. This would be 1 pi over 12. And then 2 pi over 12, which reduces down to pi over 6. So 1, 2, 3 pi over 12 reduces down to pi over 4. And let's just fill in the rest of these. So the next one would be, so that's 1/12, 2, 3, 4 pi over 12, which is pi over 3. And 5 pi over 12. 6 pi over 12, which reduces down to pi over 2. 7 pi over 12. And we'll stop there. Okay, and we'll do the same thing over with negative x. So negative pi over 6. Negative pi over 4. Negative pi over 3. Negative 5 pi over 12. Negative pi over 2. And negative 7 pi over 12. All right, so now my asymptotes, based on the work we had done earlier, are at negative pi over 12, and then pi over 4, and this period, or this distance here, is our period, which is pi over 3. Okay, that's 1, 2, 3, 4/12, which reduces down to pi over 3. And so then from here, we'll fill in our midline, a negative 1. And increments that I labeled. Halfway in between our asymptotes, we're going to be on that midline. So that's right here at pi over 12. Now, typically with cotangents, right, I'm going up as I go to the left. Okay, and I'd go up 1. So usually if this was a positive cotangent, our next point would actually be right here at the origin. Okay, but now that's been reflected. So instead of going left and up, now I'm going to go left and down because of that reflection. And so it ends up looking like a tangent function. And so then when I go the other distance between the midline point and the asymptote, I'm going to go the opposite, right 1 and up 1. And there's our entire function. Okay, and then we can just repeat this again. So every 1, 2, 3, 4 squares, I get another asymptote. 1, 2, 3, 4. Midline, right 1, up 1, left 1, down 1. Let's do one more off to the left. So left, 1, 2, 3, 4 squares. Midline is exactly in the middle. Right 1, up 1, left 1, down 1. All right, so the only thing that we haven't answered yet is that phase shift. And even though we didn't need to factor out the 3 to get to do any of the graphing part of it, I actually think the easiest way to identify the phase shift would still be to factor out that 3. Okay, so we're doing this more just to identify what the phase shift was. So let's divide out that 3 When I divide out that 3, that's pi over 4 divided by 3, which ends up being pi over 12. Okay, and again, I'll just check this. So 3 times theta is 3 theta. 3 times pi over 12 is 3 pi over 12, which reduces down to pi over 4. So our phase shift is actually taking each point and shifting it left by pi over 12. Okay, which makes sense, right? I didn't need to do that because I know that the starting asymptote was at 0. And so my new asymptote is now left at pi over 2, so that actually adds up with what I'm seeing on the graph. Okay, so you can also answer that just by thinking where your original asymptotes were and how far they've kind of moved left or right? Or you can factor it out. So a few ways you can go about doing that. Okay, that's tangent and cotangent. With that, I'm going to let you all get working on this. I don't have an answer key for this yet. I'll work on this now and then maybe come check on y'all. If you have questions, come see me, but I'll walk around and answer some questions. And let's be productive. I'm even okay with headphones today, but don't be on your phones.